Today, we're diving deep into a mind-bending concept I like to call the cosmic web. Picture the universe as this massive, intricate web, but instead of being made of threads or fibers, it's actually structured by something called dark matter. Now, dark matter is something we can't see, yet it plays an absolutely monumental role in shaping our universe. Think of it as the invisible backbone of a spider's web. Without it, the entire fabric of the universe would just fall apart.
Wait, hold on. So you're saying there's like an invisible force that's connecting everything? Wow, that sounds, pretty wild. Like a magical spider spinning a web, right? I mean, how did we even figure this out?
Exactly. The story begins with visionaries like Yakov Zeldovich, who, back in the 1970s, proposed that fluctuations in the early universe would eventually collapse into structured formations. Imagine throwing a handful of marbles into the air. Instead of just scattering everywhere, they slowly come together to create an intricate design. Each little fluctuation plays its part in building the cosmos.
Wow, that's an awesome analogy. So all these little fluctuations are like cosmic marbles? But, did we have to wait long for people to actually see this web structure in action?
Great question. Yes and no. The real breakthrough came with the Sloan Digital Sky Survey in 2000. They mapped over 2 million galaxies, and trust me, it was like getting a whole new pair of glasses. Imagine finding a gorgeous, hidden tapestry in the attic, a treasure you never knew existed. This survey revealed the filaments connecting galaxy clusters, making the cosmic web visible for the first time.
Whoa, so it took a massive galactic survey to reveal this? It's like we were blindfolded in an art gallery until someone finally took it off. But, what about this dark matter? How do we even know it exists if we can't see it?
Ah, fantastic point. While dark matter is indeed invisible, the evidence for it is pretty solid. Take galaxy rotation curves, for example. When astronomers observe these galaxies spinning, they notice they're rotating much faster than we'd expect, based on the visible matter alone. Think of it like watching your friend spinning a basketball on their finger. If they don't have the right balance, boom, it flies off. That invisible balance we're sensing is dark matter.
Haha, I love that. Your analogy makes it way easier to picture. But, what about these high-speed gas flows you mentioned? Isn't that like a recipe for some cosmic chaos?
Absolutely. Think of the flows along these dark matter filaments like a raging river. These flows are crucial because they fuel star formation and even the activity of supermassive black holes at the centers of galaxies. Here's the kicker. Much of this normal matter, what we call baryonic matter, is still pretty elusive, hanging out in what's known as the warm-hot intergalactic medium. Imagine you're trying to whip up a meal, but you can't seem to find half the ingredients in your kitchen.
Oh man, that's such a creative image, like a cosmic scavenger hunt. So, we know dark matter is out there, but what about the people trying to find it? How do they do that?
Awesome segue. Astronomers use mapping techniques like weak gravitational lensing and galaxy spectroscopy. When light from distant galaxies travels through clusters of dark matter, the light bends. It's like trying to look at a straw submerged in water. It seems all warped, right? That bending is a direct result of the curvature of space-time caused by dark matter's gravity.
So bending light equals finding invisible mass? That's such a neat trick. But, what's this missing satellites problem? Sounds like something out of a sci-fi mystery.
Haha, it definitely does. The missing satellites problem revolves around why we observe fewer dwarf galaxies than we'd predict based on our dark matter models. Picture this. You walk into a party expecting tons of friends, only to find just a few people and lots of empty chairs. Where is everyone?
Oh, that makes total sense. So, we're kind of scratching our heads here. Or maybe looking for the right doors at that party. But looking ahead, are there any new tools or projects that might help solve this cosmic riddle?
Absolutely. The future looks promising. Telescopes like the Euclid and the Vera Rubin Observatory are geared up to unveil even deeper insights into the cosmic web. And you know what's exciting? The use of AI in simulations is a game changer for deciphering dark matter's complex behaviors. It's like upgrading your tech to tackle those intricate puzzles with finesse.
Wow, it sounds like the universe is only going to get more fascinating. But, does all of this lead us to think that dark energy is involved too? Like, creating separation between galaxy clusters or something?
Spot on. Dark energy is a huge player as well, influencing the universe's fate. As it drives galaxies further apart, we might end up with galaxy clusters isolated in a vast dark expanse. The cosmic web itself becomes this intricate tapestry weaving dark matter, galaxies, and everything else together into an epic narrative of cosmic evolution.
That's so profound, but also a little scary to think about. Like, what if we are just drifting apart from everything? But what a cool journey to be a part of.